So we are still in Unit 1A, and we are on day 5. So if we go to day 5 in our journal, Unit 1A, day 5, segment addition postulate. When a point is placed on a segment, we say it's between the two endpoints. We talked about the word between a little bit yesterday. Does between mean it has to be right exactly in the middle? No. Remember, if I'm standing somewhere in this room, I can say I'm between the walls of this room. That doesn't mean I'm exactly in the middle of the room, right? So between does not have to be in the middle, right? Not in the middle. It can be in the middle, but it doesn't have to be in the middle. Okay? So when you see that word between, it doesn't have to be in the middle. Same with the word on. Okay? When it says example, place point C so that it's on segment AB. I know we're talking about a segment because there's no arrows. Segment AB. I can put that point C anywhere on that segment. I can put it real close to A. I can put it real close to B. I can put it right in the middle. I tend to stay away from putting it right in the middle so that I don't, as I'm working through the problem, start to think to myself that it is in the middle, and then I do my math wrong. So if it tells me to place a point somewhere on segment AB, I usually on purpose make sure I don't put it where it looks like it's in the middle. Okay? So super important, between and on don't imply midpoint. Okay? All right, the next note we're going to talk about, it says, when you put a point on a segment, it divides the segment into two shorter segments. So I can see when I added C to segment AB, I can see that segment AB is divided into segment AC and segment CB. Now I know if those are rays I couldn't switch the letter, but as segments, could I switch my letters if I wanted to? Yes. Yes, I can. It's just the ray where you can't switch those letters around. Okay? So you can see I have segment AC, which looks like a really short little segment. I've got segment CB, which is looks like a much longer segment, and then together they make up that whole segment AB. And knowing that, we get what is called the segment addition postulate. The segment addition postulate we will use quite often throughout the entire year. The whole year we'll use this postulate. A postulate is a rule that doesn't have to be proven. Okay? We will use the segment addition postulate in a proof, but we don't ever have to prove that postulate. Okay? And it says, if point A is between R and M, then the distance from R to A plus the distance from A to M is equal to RM, the distance from R to M. Notice there's no segment bars above these. That's how when I know to say, instead of saying segment RA, I say the distance from R to A. Okay? To sketch that picture, I have to start with my first point. Okay? I have to have that information before I can use the segment addition postulate. I have to have that I just underlined in pink before I can apply the segment addition postulate. I have to have a point on a segment, right? So R and M, if I have point R and I have point M, and if A has to be between them, that means it's got to be somewhere in the segment between them. Again, between doesn't mean it has to be right in the middle, so I like to, on purpose, make it not look like it's in the middle. Okay? So I have to have that part in pink before I can apply this postulate. Once I have that part in pink, then I can apply the postulate. Yes? Oh, I thought you had a question. Okay. Which says the distance from R to A, so this little distance right here, okay, plus the distance from A to M, so this distance right here, is going to be equal to the whole thing. Right? I like to think of it like a road trip, right? You're driving from here to Buc-ee's, that's a certain number of miles. And then you finish your trip on all the way to Houston. That's the rest of your trip. You add the distance to Buc-ee's, and then you add the next distance to Houston, and that gives you your whole drive. Does that make sense?
Yes.
That's the segment addition postulate. Okay? Another way you could think of it, I said down here, is you could think of it like an ant walking along a segment. Okay? I can think of it like an ant walking along a segment. I'm going to fold this back so I can slide it. And then I just want to know, what is the length of segment AC over here? What is the length of segment AC? So we're going to say AC equals. So the length of AC means I want to know how far is it from A to C. Notice I didn't put a segment bar when I'm going to write down what the actual length is. The distance from A to C, how far does that ant have to walk? 7.5, right? Or we had just going to add those two together. So I'm going to do he has to walk 2.5 centimeters, plus he has to walk 5 centimeters. So he's going to walk a total of 7.5 centimeters. I'm sorry, what? Okay. All right. The next one, this time I'm trying to find what is the length of YZ. So I'm not trying to find the whole length this time. I know the whole length is 10 centimeters. My little ant has already walked 5.5 centimeters. And I want to know how far is it just from Y to Z. What do I do? Subtract this time, right? I'm going to go 10 minus 5.5 to get what? 4.5 centimeters. So the distance from Y to Z is 4.5 centimeters. Make sure you're using capital letters for your point names. Yes?
Should we put a line over the capital letters in our...
No. Okay? So remember, when we don't have a line, that's when we're talking about the distance between Y and Z is equal to 4.5. If we use the bar, then we have to write it out like it's a sentence, and we have to say the length of segment YZ, and we use this symbol, is 4.5 centimeters. But if we're just going to write it like an equation, then we don't use the bar. That's a good question. Okay? I probably won't take off if you leave the bar right now, but eventually it's going to affect when we get into doing proofs with geometry. It'll affect some of the things we do with proofs in geometry. Okay? All right, so 1A, it wants to know what's the distance from J to L. So J to L, what is that total distance? What am I going to do here? Add them together. Good. So I'm just going to take that 8.4 plus the 3.9, and what am I going to get?
12.3.
12 point what?
3
centimeters. Okay. Now on the next one, 1B, if you don't like to work with fractions, that's okay. Because we have a calculator, and the calculator's really good at fractions, right? Our calculators are really good at fractions. So if we open up a new document and we don't save the old one, and we grab a calculator, and I don't know if I remember, it's literally been like a year since I put one of these over and under an overhead. Okay, so if I want to know what 3/4 is as a fraction, which we should know 3/4. What is 3/4 as a fraction?
0.75.
Yeah, if I just hit enter, it's going to keep it as a fraction because the calculator just really likes fractions. But a lot of you have been taught that you can do control enter and it will turn it into a fraction. And most of the time that works. Every once in a while it gives you the wrong answer. I personally try to stay away from doing that. But it works for the most part. And so I know I just put in the 3/4. So this is 13 3/4. So it's 13.75. Oops, I forgot my 7. Okay? Then this one I'm going to do the same thing with the 5/8, but I'm going to show you another way to do this. If I do 5 divided by 8, instead of hitting enter and then control enter, so that's enter, control, enter, that's 3 buttons, I'm going to add a little decimal right there next to the 8. And when I do that, I put a little tiny decimal right next to the 8. I told the calculator, hey calculator, can you give me my answer as a decimal? And the calculator says, you want a decimal? You got a decimal. And it gives me a decimal. Okay? So 6 and 5/8 is 6.625. So what am I going to do to find out how long QR is? Subtract. I'm going to do, for this piece right here, I'm going to do the 13.75 minus the 6.625. And what do I get?
7.125.
What are my units here?
Feet.
Feet. Make sure you're always paying attention if you have units that they all match in the picture, right? Because if one of these was inches and the other were feet, you'd have to do some fixing there before you could do that math. Okay? Questions? Yes.
Could you put 7 1/8 for the answer or no?
Yes. If you want to leave the whole thing as fractions and you give me that as 7 1/8, I am okay with that. If you want to make it into an improper fraction and leave it as an improper fraction, I like that even better because I prefer improper fractions to mixed fractions, because whatever elementary school teacher or middle school teacher who told you that improper fractions are improper, they're not improper. They're perfectly fine. Nothing wrong with an improper fraction. All right, let's look at the next page. All right, so I have an algebra problem. It even tells me I'm going to have to do some algebra. It's not hard algebra. It just says find the value of the variable if y is between x and z. And xy equals 6b, yz equals 8b, and xz equals 175. Check your work. All right, so when I look at this one, and I'm solving this one, the first thing I'm probably going to want to do is draw a picture. Because if I don't draw a picture, it's going to make this really hard. Okay? So when I see this part right here, because I have that, I know I'm going to use the segment addition postulate. Okay? But I'm going to draw it because that just helps my eyeballs and my brain connect as to what to do. So y is somewhere between, so I'm going to put my point not necessarily in between. I always go close to this end. I'm going to go close to this end this time. And y is the one in between. X and z are the ones on the ends. Okay, so I drew that part of the picture. Then the next part says xy is 6b. So from x to y, this right here is 6b. Okay? And then the next one says yz equals 8b and every year I have at least one, sometimes 4 students that come up to me and go, I don't know what 8b and means. That's just English. When you're making a list, you say this, 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 and this. That's just using English. But yz, ladies, yz is really just 8b. Ladies. And then xz, so starting at point x going all the way to z is 175. And again, notice there's no bars over these letters. That's just meaning it's the distance between the points. It's not necessarily talking about the actual segment line in between, but the actual multitude of points in between. Okay? So now when I look at this picture, I know because I have a point between 2 other points, I'm going to use the segment addition postulate. What 2 pieces out of my 3 pieces here, which 2 am I going to add together?
6b plus 8b.
Yes, I'm going to do the 6b, the left side, and the 8b, the right side, and I'm going to add them together. And that's going to give me
175.
175, the whole thing. All right, what's the first thing I want to do?
Combine like terms.
Combine like terms. So when I put these two together, 6b plus 8b, I have 14b. Then what?
Divide both sides.
Right,
by 14.
divide both sides by 14. And so b equals 12.5. Am I done?
No.
No, because it tells me to check my work. So I want to check my work. I did find the value of the variable, so that part's done. That's my answer. And I don't have any units here, so I don't have to write units. If you want to write the word units out, you can. But to check my work, I need to substitute this b back in. So I need to put a 12.5 here, and I need to put a 12.5 here, and see how long those segments are. So the first one, what is 6 times 12.5?
75.
75. So this side is 75. So what does the other side have to be? It better be 100. I don't want to just put that it's 100 though, because that's me not checking my work, right? I want to plug it in and make sure it really does equal 100, because if it doesn't, I know I did something wrong. So what's 8 times 12.5?
100.
It is 100. So then I can check, do these two really add up to 175? Yes, they do. I can feel confident that I did my math correctly. I can feel confident that I did my math correctly. Okay? If we were going to do this as a proof, we have, how many givens do you think we have here?
3.
We have 4 givens. Okay? I have to write this one down as a given, because remember, I told you in order to use the segment addition postulate, you have to have that a point is between two other points. So you would have to write, you would have to write this as a given, and then after you wrote that, then you could write that xy plus yz equals xz. Then once you have these other givens in there, then you can use substitution and substitute into that equation. So in order to use it, you have to first use this as a given. Then you have to write the equation with letters. Then you can substitute into the equation. And we're going to do a proof to practice it. Okay? All right. Let's move on to the next one. Find the value of a. If y is between x and z, xy equals 3a, yz equals 5a minus 4, and yz equals 14. Okay? So let's say you didn't want to draw a picture because you're like, pictures are for silly people, which is not true. I always draw a picture, even when I'm just doing it for practice to get ready for class. I always draw a picture, but let's say you just don't like to draw. Okay? Find the value of a. Y is between x and z, right? So we know that y is between x and z. Now, I need to know where those letters are as to what I would substitute in. Like, which two of these do I add together? Which one is the one that equals on the end? It's real tempting to say add the two together that have variables and then they equal 14. But let's see if that's what really happens. If y has to be between x and z, that means x goes into y and then y goes to z, right? So x goes to y and then y goes to z, because my segment is going to go x to y to z. We would add those together, and then it's going to give me that whole segment, xz. If that didn't make any sense to you, that's why you want to draw a picture, right? So that's why you'd want to go, okay, x and z, y is between them. I'm not going to make it look like a midpoint, okay? And then you'd be able to see, okay, yeah, it's xy plus yz, the left side plus the right side, equals the whole thing. Okay, sometimes that's hard to see. It's hard to figure out if you don't write the picture. Okay? Then I have these other givens, right? I know that xy is 3a, yz is 5a minus 4, and yz is 14. So now I can substitute in, right? I know xy is 3a, yz is 14, and that equals xz, which is 5a minus 4. So notice I didn't just add the first two together and say it equaled the third one, right? I didn't add the first two together. I added the first one and the last one together, and it equaled the second one, which we might, if we didn't draw a picture, if we didn't really think about it, we might have got those in the wrong place. All right, am I going to combine like terms to solve this? Why not?
Because the equal sign is in the way.
Right. If I look at this on the each side of the equal sign, 3a and 14, those aren't like terms. 5a and minus 4, those aren't like terms. What am I going to do?
Subtract 14 from both sides.
Subtract a 14 from both sides. We can do that. When you're doing the subtraction, okay, on some of your proofs, I told you that if you needed to do the work in between, the steps in between, they should not be noticeable. They should be like just so you can barely see them, so you can see what you did. Some of your proofs were real messy because you were doing your work real big and crossing out things, and this part here should not be written on or affected. Okay? So if you need to write the little minus 14 so that you can see what you did, I shouldn't then see big X's and things over everything, because that's not technically part of the proof, and it makes the proof very difficult to read. Okay? So 3a plus, that's really a 0, is just 3a, equals 5a minus what?
Negative 18.
18. Minus 18.
Oh, minus 18.
Yeah, because if you do minus a negative, it becomes positive. We wouldn't do that. All right, now what?
Subtract 5a.
Subtract 5a, and again, if I need to write it down, which you don't have to, but if I need to write it down, I'm going to do it real small and real light so I can barely see it, so when somebody's looking at it, they hardly even notice it's there. 3a minus 5a is?
Negative 2a.
Negative 2a. Equals, the 5a becomes a 0. 0 minus 18 is?
Negative 18.
Negative 18. Now what?
Now you divide by negative 2.
Divide both sides by negative 2, and again, you should barely see it if you're going to write it. So I end up with a equals? 9. Okay? Then it says to check your work. Okay? I know that xy equals 3a. So xy equals 3a, which is 3 times 9. So how far is it from x to y?
27.
27. So x to y is 27. Okay? And then xz is 5a minus 4. xz is 5a minus 4. And a was 9. What's 5 times 9?
45.
Minus 4?
41.
So x going all the way towards z is 41. And then yz is 14. So now check it. Does 27 plus 14 equal 41? Yes. Awesome. It works. That's checking your work. Who's ready for a proof?
Yeah.
Awesome. Okay, let's do a proof. Proofs using segment addition postulate. It's always helpful in geometry, even in proofs, to draw a picture if one isn't provided. So guess what I'm going to do first?
Draw a picture.
Yeah, because my first given is a picture. It's given A is between R and M. So actually I'm going to set up my proof first. I'm going to do my statements, where my math goes, and my reasons. And then watch this. I'm not saying this is a long proof or anything, but alright, so what I like to do is as I write my givens, I will draw the picture as I write the givens. So my first given, A is between R and M. is given to me. And if I draw a picture, what letters should go on the end points of my segment?
R and M.
R and M. And then A goes somewhere in the middle. I'm not going to put it exactly in the middle in case it's not a midpoint. I'm going to put it like, I don't know, over here. Okay? And that means when I'm done, my picture might not be to scale. Remember back here when we did this one and I said, I'm going to put the Y closer to the Z?
Yeah.
Well, the left side is 75, the right side's bigger. But notice how much smaller it looks, right? So my picture's not to scale, but mathematically it still works, and that's what's important. Okay? All right, so that's my first given. Check, done. Okay? Now, I have two options from here. I can either do something with this, because this is the first part of the segment addition postulate, which means now that I've got this, I could use the segment addition postulate, or I could write my other givens. It's up to you. Which would you prefer?
Write the given.
Let's write the givens. So RA equals 7A. Notice there's capitals and lower cases, and those are important. Okay. As I write it in my proof, I also like to label my picture RA is 7A. Okay. And then sometimes I'll even check it off over here so I remember I used it. A to M equals 5A. Do I put the word and next to it when it's in the proof?
No.
No, because it's a separate line, so it's not like I'm not technically making a list. Okay? So that's used, and I'm going to put it over here. This is 5A. That's a 5. It's hard to tell. Okay? And then the last one, RM equals 6A plus 24. And these, I'm going to do it this way. I'm just going to say all three of those are given. Oh, I didn't add the last picture. 6A plus 24. All right. The next step, it's really tempting to skip a step and make a mistake. What do you think the next step is? Now we're scared to say because they said it's tempting to make a mistake.
I think we are building
We are going to use the segment addition postulate next. If you want to put SEG, ADD, POST, seg, add, post, I'm okay with that abbreviation. She says after she waited for you to write it all. All right, but what goes next to it? Uh-huh. RA what?
Plus AM.
Plus AM equals RM. Good. It's real tempting for people to skip that and go straight to having already substituted everything in, because you look at your picture and you go, oh, I already know to add these two together and it's going to equal this one. And then when I mark it wrong, you go, Miss, you know what I meant. And I go, no, I didn't. Okay? So don't skip that step. That's an important step. So now what can I do?
Substitute.
Now I can substitute in. RA is 7A. Plus AM is 5A. You can do all your substitution in one step. RM is 6A plus 24. And that is all substitution. All right, what's next?
Combine like terms.
Combine like terms. Don't call it addition. It's combining like terms. 7A plus 5A is
13.
12 or 13?
12.
12A equals 6A minus or plus 24. That was combining like terms, not addition. Now what? Subtraction, property of equality. What are we subtracting on both sides? 6A. So 12A minus 6A is 6A. 6A minus 6A is 0. And 0 plus 24 is just 24. We subtracted 6A on both sides. So subtraction, property of equality. Okay, now what? Divide both sides by 6. So A equals 4. What do I write over here? Uh-oh. Division, property of equality. Division, property of equality. Okay? And I'm done, right? Why am I not done? I don't need to check anything. Why am I not done? I'm trying to prove that AM equals 20. What do I do to prove that AM equals 20? I need to do substitution. I already have in my proof that AM equals 5 by 8. I don't have to rewrite it. Once it's there for everybody to see. You don't have to rewrite it. So now I can say AM equals 5, and instead of A, I know A is now 4 because I can substitute it in. And so now 5 times 4 is 20. AM equals 20. What do I put?
Multiplication.
Wait, where did the 5?
Simplify?
Oh, okay.
Yeah, that. Simplify when we do that multiplication. That way we don't get it confused with the multiplication property of equality that says multiply on both sides. Because we were only multiplying that 5 times 4 on the one side. Okay? Any questions? I know this is like our biggest proof we've done so far. Any questions on it? We're good with segment addition? Alright, on your assessment, you don't have to do a proof unless it asks you to do a proof, and guess what? It doesn't ask you to do a proof, so you don't have to do the reasons next to it, right? You just have to do like we did in the first part of the notes, where you're just solving the problems. Okay?